So, solving linear equations. This is something that you guys have been doing for an awful long time. This is mostly just for review so that you get the idea of what's going on with it again. Now, one of the things that you should understand is this idea of a solution to an equation. I honestly can have all kinds of numbers that can get put into it. Not all of them will work. When we are taking a look at whether something works or not, we want to determine whether it's true or false. When we mean, is this true? Is 2 plus 3 equal to 5? Is that a true statement? X equal to 3. Is that true? Could be. We consider this conditional simply because it depends upon what condition X is. Is 5a minus 12 equal to 13? Could be, again, it all depends upon what a is. And when we're going through and finding solutions for this stuff, we want to see where the equation is true. So that's how we go through and find what is going to be equal for a that makes it actually work. So these are the properties. And you guys have done this stuff before. You always got to kind of think of it as balance. I know I told my goofy little story in freshman year when start off with this in algebra, that this is really just like a teeter-totter. But in my world, I got the industrial strength teeter-totters, so that you can't break them, right? That's the only entertainment in my world, so it's kind of a sad world, right? But, when the little kindergartners get there, they see the teeter-totters, and they think it's the greatest thing in the world. They hop on the teeter-totters, but they don't go anywhere. Reason being is all the kindergartners are all the same size. First graders are a little bit bigger, second graders are a little bit bigger, third graders are a little bit bigger, so on and so forth. So the biggest ones in the school are the seniors. So it's no wonder why the kindergartners get on it, they can't go anywhere, right? They just sit there and they balance out perfectly. Now, unfortunately, due to circumstances completely and totally beyond our control, there are some seniors that get a little on the bad side. See, and these bad seniors, they wait for the kindergartners to get on there, and they run up to that industrial strength teeter-totter, jump on it, boom, and they launch one up in the air. Okay. But fortunately, we also have good seniors that counteract it. So the good seniors watch when they see these not so good seniors come running up to it, and they time it just perfectly, and they boom, jump on it by their industrial strength. Balances out again. The moral of the story is as long as you do the same thing to both sides of an equation, just like on the teeter-totter, everything stays balanced. So, if I add something to one side, I have to add it to the other side. If I subtract one thing to one side, I have to subtract it to the other side. If I multiply one thing by on one side, I have to multiply on the other side. If I divide by one side, I have to divide on the other side. I always have to do the exact same things to keep it balanced out. So, we use these ideas to help us solve these things. Now, when you're writing this stuff out, again, you can't do this stuff in your head. And if you try, all you're going to end up doing is having problems later on. So, subtract 12 to both sides, subtract 12. So that gives me minus 5x is equal to negative 35. Divide by negative 5, divide by negative 5, and x is going to be equal to 7. So we say that 7 is the solution. Why? Because 7 is the value that when we plug it in actually makes it true. That's all it is. If I try this, I got variables on both sides. Now when I solve this one back here, x happened to be on the left side, numbers happen to be on the right side. We can move things around so that we get variables on one side, numbers on the other side. Generally, I like to go and move the variables to the left side, all the numbers to the right side. It really won't matter. Sometimes I like being lazy and keeping my variables positive. So it is perfectly legal to do this. Subtract 2n, subtract 2n, as long as I do the same thing on both sides. Because here I had a positive, now it disappears. Here I'm going to add 3, so I have to add 3. Is that going to work for us? The answer is no, because I just took everything here, moved it over there. So if I want my variable to be on this side and the numbers to be on the other side, what do I got to do to get rid of the 25? We'd subtract 25, subtract 25. So what I end up with, that disappears, that goes to negative 28. This goes to 4n. That disappears. Now, divide both sides by 4, divide both sides by 4, and I get negative 7 is equal to n. So the solution to this one is negative 7. Distributive property. Just use it first before you do anything else. So the 12 goes to the r and to the 3. So I end up with 12r plus 36 is equal to 2 times r gives me 2r plus 10, and then it's just going to be minus 3r. Now, one of the other steps that we have in here is adding like terms. We want to put things that are the same together before we start moving things around. So this 12r and the 36 on this side are fine. This side over here, I've got 2r here, and I've got a minus 3r here. We want to combine those like terms before we continue on. So this turns out to be negative 1r plus 10. So before you start moving from one side to the next, you want to make sure that you have a variable and a number, variable and a number. You want to have it simplified down to that. Now, I'm going to add 1r to both sides, subtract 36, and that gives me 13r is going to be equal to a negative 26. Divide by 13, divide by 13, and r turns out to be equal to negative 2. For the most part, when you're working on these, you're going to get nice, easy numbers, simply because it's the understanding of how you do it. Okay? Once you understand how to do it, yeah, then they'll start throwing uglier numbers at you, and you get decimals and fractions and all kinds of other wonderful things going on. But there's always a way to deal with those easily. So who likes fractions? Absolutely nobody likes fractions. Depending upon how you want to do this, you can work with the fractions, add like terms, and that'll all work. But there is a trick to getting rid of the denominators. And I'll show you what the trick is. If I've got 1/2 x plus 4 is equal to negative 2/3 x plus 1/2. I could multiply this thing through by a number that'll wipe out a 2 and wipe out a 3. They cancel out. So what would be a good number to cancel out a 2 and a 3? Well, if you multiply 2 and 3 together, you get a 6. So if I multiply everything through by a 6, so that means that it's going to be 6 multiplied by 1/2 x plus 4 multiplied by that 6 is equal to 6 multiplied by that negative 2/3 x plus 6 multiplied by 1/2. It kind of looks similar to the distributive property, where this gets multiplied by that, by that, by that, and by that. But we don't say distributive property because it doesn't go across equal signs. So now, simplify. This cancels with this, and I get a 3. So I end up with 3x. What am I going to end up with here? Well, what's 6 times 4? 4. Can't cancel anything out. 3 cancels with the 6 and I get 2, so I get minus 2x. 2 cancels with the 6 and I get 3, so it's plus 3. So, question? So, subtract 24, subtract 24, add 2x, add 2x, and we end up with 5x is equal to, this turns out to be, negative 21. Now, am I going to get a nice, easy number out of this one? No. If I divide both sides by 5, divide both sides by 5, I end up getting x is equal to, negative 21 over 5. Should I turn this to a decimal? No. You were working with fractions, so stay with fractions. Okay? If they give you decimals, then put in decimals. That's fine. But you can leave it like this, or if you want to, you could write it as negative 4 1/5. But whenever we're working with algebra, this is going to be the form that is used most often, okay? Because we deal with numerators and denominators. So let's try this one. It says, according to the 2000 census, the 3 smallest cities in the United States by population are North Dakota, Vermont, and Wyoming. Total population is 1 million. Let me give that to us. Vermont has a population of that. North Dakota has that. Write and solve an equation. Now I realize that you guys would simply do this. 1, 7, 7, 4, 7, 7, 9. You'd subtract off 623, 908, come up with a number. Then you'd subtract off 635, 867, and come up with the next number. That's the easiest way to do it, correct? Problem is, they want this idea of writing it in terms of an equation. So if we do that, it's going to be similar to this, but not quite the same. X is going to be added, because I don't know what the population of Wyoming is. Now, could have I used the W? I could use anything I want there. Plus the other populations. 6, 3, 5, 8, 6, 7, plus 6, 2, 3, 908 is equal to 1. 7, 7, 4, 7, 7, 9. It's going to get us to the same place, but we're supposed to have an equation. So it's going to be x plus. Can I add these two together? And if I add those two together, well, let's just do this. So we get 635, 867, 623, 908, and I end up with 1, 2, 5, 9, 7, 7, 5 is equal to 1, 7, 7, 4, 7, 7, 9. Subtract the 1, 2, 5, 9, 7, 7, 5 to both sides. And you'll end up getting x is equal to, go back to the calculator, and let's see, we take 1, 7, 7, 4, 7, 7, 9 minus 1, 2, 5, 9, 7, 7, 5, and I end up with population for Wyoming at 515,004. I realize that this is nothing new for you guys, but please get into the habit of writing it out so that when we get to more complicated expressions, you know what to do. So, I'm going to give you a minute and have at this one. David, what'd you get for an answer? 4. Isn't 4, David? Yeah. Huh. David, what'd you get as an answer? You got 4. So 4 is, this one's 4. Okay, let's double check. So I've got 8p minus 21 is equal to 11. Add 21 to both sides. So I end up with 8p is equal to 32. Divide by 8, divide by 8. T is equal to 4. Absolutely correct. Okay. Not bad, right? Just make sure that you show the work on it. So I'll give you a minute and have at this one. All right. 6. Okay. 42. See how that turns out. So we've got 5r minus 12, negative 4r minus 30. So add 4r to both sides. Then I'm going to add 12. So that turns out to be 9r. Over here turns out to be, I can see where you get the 42 there if you had the wrong sign there, right? Okay, so we can do that too. Back up. But if I do plus 5r to both sides, does that wipe out the 5r over here? No. So if I wanted to deal with that 5r, I would have had to have made sure that I subtracted it to both sides. Because I don't want it here, okay? Then I'd have to add 30 because I don't want the numbers here. Like I said before, it doesn't matter as long as you shift things around and get the variable to one side, numbers to the other side. So it disappears here, and here it's going to turn out to be 18, right? That's going to give me a negative 9r, and this disappears. So if I do this step and I end up with numbers and variables in places I don't want, I got to back up and change a sign or something. So now when I divide by negative 9, divide by negative 9, I end up with negative 2 is equal to r. Now if I would have done it the other way, it would have worked out exactly the same way. So, questions on that? I suppose I could go back and do it the way I was planning on doing it, just to see if it actually turns out to be that way. So, go back to what I was going to do. I was going to add 4r, add 4r, add 12, add 12. So that gives me 9r is equal to, and this turns out to be a negative 18. Divide by 9, divide by 9. R is equal to negative 2 again. So it does, like I said, it doesn't matter which way you go. Variables to one side, numbers to the other. So, let's give that one a try, see what you can come up with. 3. Noah, what'd you come up with? 8. Okay. So, did the distributive property. So you should have gotten 6y minus 30 plus 4y is going to be equal to 5y plus 2. So am I right so far? No. Okay. So if I add like terms, that's going to give me 10y over here minus 30 is equal to 5y plus 2. So far, so good? Okay. Subtract 5y, subtract 5y, add 30, add 30. So I end up with 5y is equal to 32. If I made a mistake? Yes, sir. Yes, I do. So if I forgot about that and I missed that, so 5 times 2, that's not going to be 32 over here. This is going to be 5 times 2, which gives us to be 10. So I got to add 10 to that, so I end up with 40. Divide by 5, divide by 5, and y is equal to 8. Absolutely correct. So be careful about that distributive. Sometimes you just miss those things. Okay. All right, so let's give this one a whirl. Ready? Okay, give you a little more. Ready now? So, give this a whirl. See what you're up with. Oh, Mr. Garthus is gone. Kaylee's gone. Bummer. What do we got? Jordy. What'd you get? Okay. So, in that case, what we're going to do is we're going to start off with negative 3/4 s minus s. And minus 3 is equal to 1/3 s plus 1/4. So my question would be is what number could I multiply by that would cancel with a 4 and a 3? 12, absolutely correct. So I'm going to multiply everything through by 12. So that means it's going to be 12 multiplied by negative 3/4 s. Again, well, I'm not used to writing out s's or s's, so then it's going to end up being 12 multiplied by the 3 equals, and then I've got the 1/3 over here. I'm going to make sure I write that while I'm doing this. Okay. So every one of these has been multiplied by a 12. Does that make sense? Yes? With me? Okay. So if this is what's going to happen to it, 4 cancels with the 12, and I get a 3. 3 times negative 3 gives me negative 9s. Do you agree with that, Jordy? Okay. Now, there's no fraction here to cancel out, so this is just going to be minus 36. Now I got a fraction here, so this 3 can cancel with the 12, and I get a 4. So this turns out to be just 4s. Got another fraction. 4 cancels with the 12, and I end up with a 3. So I get plus 3. Right? Okay, so the math looked good so far. So now I'm going to add 36, add 36, subtract 4s, subtract 4s, and I end up with negative, and let's see, that would be 13s is equal to 39. Divide by negative 13. Divide by negative 13. And I get s is equal to negative 3. Okay. So yes, it is a lot of work to go through and do, but if you don't bother writing it out, it's just not going to happen for you. You've got to go through and do that. Okay. Questions, concerns, thoughts? So, got one more for you. I'm going to give you a couple of minutes, or give you a minute and 90. Think about this one. See what you come up with. So, it's total What you got? Yeah, no, because you didn't do it, did you? Not even in your head. So, Aaron is traveling 950 miles from Phoenix to Jackson. He leaves Phoenix driving 410 miles before stopping in gas at Cortez, makes one last stop in Rock Springs before traveling the final 180 miles. Write and solve an equation. So, if I decide to start off with 955 equals, what else am I going to write down then, Cole? What am I going to write down next? Got numbers there. I already started off with 599 or 955. What comes next? Somebody's going to have to help. So, 410 plus 180 plus our x. So we end up with 955 is going to be equal to, add those together. So that's going to give us 590 plus x minus 590 minus 590. And what do we end up with? 365 is equal to x. It's 365 miles in the last place. All right.